All right, so take a moment to breathe after the stress of the technical problems, and I'll get started. So this presentation is going to be about writing native Linux desktop apps with JavaScript. My name's Philip Chimento. I'm joining you from Vancouver, BC, Canada, and this is where you can find me on GitHub and Twitter and stuff like that. So a bit about this talk. I'm the maintainer of GJS, which is the JavaScript bindings to the GNOME platform. And GJS is an environment that people can and do use to write apps in JavaScript for the Linux desktop. The most famous one is probably the IRC client Polari, but there's also the Flatseal, the permissions manager, and Foliate, the ebook reader, and commit message editor, and things like that. A lot of these apps are available on Flathub, which means that even though they use the GNOME platform libraries, they work anywhere Flatpak is available, which is on, I think, pretty much all major Linux distributions. Traditionally, at GJS, we've been aiming our documentation at programmers who have already written desktop apps in other languages, other programming languages, and want to use JavaScript for convenience or rapid development, because it's faster than writing some compiled languages like C. But one of the reasons we always give for even having JavaScript bindings in the first place is so that it's more familiar to web developers and they can get started quicker on our platform. And so this talk is about answering the question, is that really true? I was curious about whether I could present a talk from that perspective. And this talk is going to be sort of an experiment, and it's been brewing in the back of my mind for a while and in conversations with other people. So a bit about what it is and isn't. This talk is for people who know JavaScript from other contexts like front-end web development or Node.js, and are interested in how they could use their existing knowledge to write an app for the Linux desktop. It'll consist of a walkthrough with some digressions here and there, starting with setting up a project skeleton and setting up your developer tools, to things that you might want to be aware of while coding, to distribution via Flathub, which I hope there's not too much overlap with Dan and Arjan's excellent talk that we just listened to before mine. So one thing to note, a few years ago, this talk would have only applied to the GNOME desktop because these technologies like GJS and GTK, they're part of the GNOME platform. But ever since we have Flatpak and Flathub, you can basically write and publish an app using whatever desktop platform you want, and it'll work on any Linux desktop. So the other thing with this talk is a resource that you can go back to later and reread and click on all the links in it. It's shared at this this URL right here. You can go there now if you want, but there's no reason to because I'm sharing the screen. Anyway, this talk is not going to be a tutorial on how to code a desktop app because there are plenty of those already. There's a link to one in the slides. Another thing this talk is not, it is not presented by an experienced web or Node developer. I do know some things about web development in JavaScript, but I'm not really familiar with the latest tools and best practices in that environment. I guess at heart, I'm a Linux desktop programmer, and in my day job at Igalia, I work on JavaScript engines in browsers. So like I said at the beginning, this is an experiment for me. I might get some of these things wrong. There could be better ways to do things. So the cat is telling us to get on with it already. Let's go. I'm going to talk first about the process of setting up your project and how you might want to organize your development tools. Before we do that, we need an idea for an app. There's a long tradition of having an example app in the GTK documentation called Bloatpad, so I stole that name. Unfortunately, I did not make up this pun. I love making up puns, but I didn't make up this one. You can see my sketches for the app in the background here. And the tagline of this app is going to be the unnecessary note-taking app, because really there are plenty of good note-taking apps already, and Bloatpad is not going to shatter any paradigms. So the first thing we have to do is have something to start with. one thing you could do if you're using GNOME Builder as your editor, or even if you're using a different editor, you can still launch GNOME Builder and create the project. The new project dialog, which I've shown here, it allows you to create a project skeleton. And then there's also this GTK.js app repository that you can use as a starting point. Both of these are quite similar to each other, and I think one was probably based on the other. But both of them give you a project skeleton. The skeleton looks kind of like this. Here's a list of what it gives you. And I'll come back to most of these things at some point in the talk. The first item on the list, a Meson build system. A little bit about build systems. The one included in the project skeleton is Meson, which is popular for compiled languages, although I'd say it's a pretty unfamiliar system for people who develop only in JavaScript. Meson is great, and you'll definitely need it if your app is going to include any native code that gets imported into JavaScript, which many desktop apps eventually end up doing, although I'm not going to cover that in this talk. So if you start an app from scratch, I would recommend keeping Meson as the build system. But if you know the JavaScript ecosystem, you'll be familiar with Yarn. Yarn is similar to NPM, which may be even more familiar. But Yarn will allow you to easily install popular JavaScript development tools like ESLint. NPM would work for this as well. So what I've done here is created a package.json with Yarn in it and put this snippet into it in order to wrap the most important Meson commands. So if we have this snippet, we can just do yarn start, and we'll see the skeleton app run. It's the one that you get in the skeleton is just a hello world app. So a couple of other things about other tools from the excellent JavaScript tooling ecosystem, which is honestly in a lot of ways quite a lot better than the tooling ecosystem that we have for desktop apps. So we should take stuff from there that's good and useful. Linting. Prettier is, I guess, what they call themselves an opinionated code formatter. I guess you can disagree on whether its style is the one you prefer or not, but in the end, for a new project, just installing it and doing what it says is easy, and it frees you from ever having to worry again about code style. And I found it's still good to use ESLint together with Prettier in order to catch things like unused variables and things like that. So you can use Yarn to install those locally and add another snippet to your package.json. TypeScript is another really prominent part of the excellent JavaScript tooling ecosystem, and it mostly works on GJS, thanks to the hard work of Evan Welsh. It does require a little bit of manual setup. You can go to this link in the slides to find out more. You can use it in two ways. The simplest way is to write regular JavaScript and use the TypeScript compiler at compile time to verify the types. This is like static analysis. And this mostly works. Again, it requires writing some type annotations in dot comments occasionally. And you can also write TypeScript code directly and transpile it to JavaScript. That works with GJS too, although I haven't done this myself yet. There are hundreds or thousands more developer tools and build tools in the JavaScript ecosystem. A lot of that ecosystem revolves around bundling. Bundlers, I think, are probably not needed when you're writing a native desktop app. The default project skeleton, it includes build code to put all of the JavaScript sources and data files into a gResource bundle, which is a binary blob that's loaded into memory at startup, and it makes module imports lightning fast, which is quite different from the situation on the web. So we don't need bundling for that reason. Another thing that bundlers do is tree shaking. And this is really vital in web development, where you either have to shake the tree to remove library functions from your dependencies that you aren't using, or you have to use thousands of tiny dependencies that do only one thing, like the infamous left pad. This isn't so vital in our situation with a desktop app, because we have an entire platform in the Flatpak runtime in the form of C libraries that have their own JavaScript bindings, and it's there whether we use it or not. But still, tree shaking is useful to eliminate dead code in your own code base. But instead of using a bundler, there are other packages such as find unused exports that you could use for that. Another big thing in the JavaScript build tool ecosystem is minifiers. That probably isn't needed either for a desktop app, because with the G-resource bundles that I mentioned, we only do the disk I/O once at startup, and there's far less JavaScript code than in a typical website that bundles all of its dependencies. The load time is not really a problem. You might want to use transpilers such as Babel or other things that implement sort of these compile time transformations on your code. Now, these will probably work with a bit of custom configuration. It depends on what exactly you're transpiling. Something like Babel, you might not need it at all because you don't need to support old browsers and old engines in your app. You can just target the latest version in the Flatpak runtime. So a lot of the use cases of Babel, you can just write modern JavaScript by default, and you don't need to transform anything. You might use a bundler if you use runtime dependencies from NPM, and I'll have more about that later in the talk. But first, assembling the UI. I don't know what this cat is doing, but it's building something. But UI, so tools for constructing a UI is probably where in the desktop platform we lag farthest behind the web in developer experience. Because it's very simple. The web has HTML, and any browser is automatically a tool for displaying it, editing it, and debugging it. That's not the case with desktop UI files. So in the platform that we're using with GTK, we have there's an XML format for UI description files. So this kind of XML file plays roughly the same role as HTML does in the trinity of HTML, CSS, and JavaScript. But unlike with HTML, there is another alternative that's actually widely used. This alternative is that you can assemble your UI in code. If you come from web development, this sounds kind of ridiculous. Building your UI in code is roughly the same thing as building up a whole web page's DOM using document.createElement in your code. That would be really inconvenient, and it's not really a feasible alternative. But this is different with GJS because the GNOME platform has a heritage from C, where originally building your UI in code was the only option. So the APIs to do it are a lot more convenient, actually. But on the other hand, in web development, we have tooling like JSX, which we do not have in GJS. So there are other alternatives which are not open to us developing a desktop app. So I guess the big question is, do you want to do it in an XML file, or do you want to do it in code? And here's an example of what each option looks like, a snippet of code doing the same thing. On the top is the XML file, and on the bottom is the code. So you can see the XML file is quite tedious to write by hand. We have, on the right of the screen here, we have the Glade UI designer, which is a program that allows you to visually assemble the UI, and it outputs one of these XML files. Sadly, it currently only works for GTK3, and if you want to use GTK4, you could write the UI file by hand, or you could first build it in GTK3 and then use a tool to do the initial conversion and then maintain it by hand. This is not really a good developer story, but luckily, work on a replacement is already underway. There's actually on several fronts. Yeah, for now, I'd recommend using GTK3 or using Glade to generate an initial file and then converting it to GTK4 and then maintaining it later by hand. So this is what the front page of the app looks like after I built it in Glade, and I used the preview function to render it in a window. So you can see here the icon is it's sort of it stands out more than we'd like it to, and it's also slightly off-center due to the way that the symbolic icon is aligned. These are things that we can fix with CSS, just like we would on a web app. So you can go back to Glade and you can give your UI widgets particular CSS classes, or you can add CSS classes in the XML file by hand, and you can reference them in your app's CSS file. There's an example of that here on the slide. There is a fairly big difference between CSS from the web and CSS in a GTK application. It's it's the same syntax, and it's the same box model for margin and padding, and it's largely the same properties that you can set. But the positioning model, which personally I find the most confusing part of CSS on the web, it's completely different. In GTK and the other associated UI libraries like libhandy, they have a much more flexible design language of layout containers to work with. In HTML, we just have div and span, and that's all. So, and you can use CSS to make one of those into a flex box. But I mean, this richer design language of layout containers means that the responsibility for positioning things mostly shifts to the UI file. So there's no position absolute or float left in the CSS that we have on the desktop platform. So here's what that same preview looks like when I applied that CSS to it. So now you can see the icon isn't quite so prominent, and it's got a shadow now, and it's got these extra pixels of padding, which visually aligns it better with the button. So now that's done, the UI looks mostly like we want it to. We have a base on which to build. And it should be somewhat familiar if you're coming from a web app background. So now it's time to write some code. Kat does not want to write some code, but I do. So I'll show you some of the things that you might need to know about the GNOME developer platform, and I'll compare it to things that might be familiar for Node.js developers. The most important thing is that we have API documentation on this address here in the slides. This is for the GNOME platform, and it's for the JavaScript binding version of it. One thing that might not be familiar if you're coming from a Node background, if you're browsing the API, you notice these sections for properties and signals. These exist because the UI elements inherit from GTK widget. And that's a class that provides things such as properties, signals, and CSS element names. A GTK widget in this platform plays roughly the same role as a DOM element in HTML. You'll find that, I guess, the GTK widget relies on object orientation much more. DOM elements have an inheritance hierarchy too, but for a lot of applications, you don't even need to care about that. For GTK widgets, you kind of do. And the interesting thing that's different from the web platform is GTK widget inherits from gobject.object, which actually, that's the class that provides the signals and properties functionality. So even things like files and output streams and network requests, they have properties and signals. And this is kind of like Node, where a lot of objects are inherit from event emitter, but it's not the case for everything. In GJS, really everything has properties and signals almost. There's ES modules. This is something new that you might not realize it works natively in GJS. This is new in the latest version of the Flatpak runtime. We have you can just import ES modules. So this is another initiative thanks to Evan Welsh. This is the thing that for the web platform you have to use bundlers for a lot of the times, because you can't count on users' browsers being able to support ES modules. But we support them natively. You can just use them. Another thing is about async operations. In the GNOME platform, so what we have in GJS, all the I/O is cancelable as well, which is something that Node asynchronous I/O doesn't always have. In GJS, it works using callback style, but we have some experimental support for promise style. And you can opt into it for each method with this gio.promisify thing at the start of your program. That sort of signifies that you want to use the experimental support for that method. Once you've done that, then you can use it, like in the code example down at the bottom, with await. So this experimental support was actually done by an Outreachy intern, Avi Saillant, a couple of years ago. And we have another Outreachy internship that's still in the application period for working on making this support just part of the platform and not experimental anymore. So look out for improvements here coming soon. There are lots of runtime libraries that if you're coming from a web or node background, you might want to use. One of these libraries from the node ecosystem. Most desktop apps don't end up doing this because there's a lot in the platform already, but in many cases it is actually possible to do this. So the first thing you want to do, like, it may or may not work. So the first thing you want to do is check if you actually need to depend on this library. In some cases, you really don't. A library might be something that the GNOME platform already provides in another way, like network I/O, or it might be a dependency that sort of abstracts over different versions of browsers, and you might not need that because in the desktop platform you can target modern JavaScript. If you do need the library, you start by checking if it has any node dependencies and check if it ships an ES module entry point. So if it doesn't have any node dependencies and if there's an ES module, great. You can probably just copy that module into your sources, import it directly, and it'll work. If there's not, it might ship a browser bundle, which will probably already work. Some modules do that. And if it doesn't have that, you can build your own bundle with a tool called Browserify that's available in NPM. So here's how to do this Browserify trick. You add this -s option, and that builds a UMD module. And UMD stands for Universal Module Definition, I think. So you can import the UMD module, and it has a side effect, which is to install the library as a global object. So yeah, the global object kind of gross. This is the best way that I found to do this so far. It's not ideal. So it would be really cool if somebody would write a rollup plugin for GJS modules or something. Rollup is another bundler tool from the node ecosystem. But there might be a better way that already exists that I haven't found yet. But in the examples that I'll show in a minute, I'm going to use this trick. So as an experiment, I decided to take a look at the top 5 dependent upon NPM libraries. There's a link here with somebody who compiles and updates this list by some metric. And I see if I could make them work in a GJS app. So the top of the list is Lodash. It's a very popular utility library. First of all, you should consider if you really need it. Many of the functions that it provides are actually no longer necessary if you can target modern JavaScript. So the example here with Lodash.defaults, it can actually be replaced with object destructuring, which is a newer JavaScript language feature. Other things you might still need it for. Lodash provides an ES module with no dependencies in the Lodash ES package. So you can copy this file from this package into your source directory and import it into your code. And then it just works. Number 2 on the list is Chalk. That's a popular library for printing ANSI color codes to the terminal. And that does not ship a browser bundle. It does ship an ES module, but it imports other modules that need node module resolution, so we can't use it directly either. So for this one, I used the Browserify trick to build a UMD bundle. And then I also found that I needed to make one edit in that bundle because the browser bundle that Browserify generates, by default, the ANSI colors were disabled because browsers mostly don't support them. So I had to make this one edit, and after that, it worked. Number 3 on the list is Request, which is a library for network I/O. It's a very popular library, but it's been moved to maintenance mode because there are better ways to do requests in modern JavaScript. And there is actually one in the GNOME platform. libsoup is the GNOME platform's network I/O library. And so I'd recommend using that. It integrates with the main loop. And in the upcoming libsoup 3, there will be an API that will integrate even better with await in JavaScript. So I've shown the code sample that's on Request's website, and then the bottom code sample is doing the same thing but with libsoup. So despite Request being one of the most dependent upon modules in the web ecosystem, in desktop app code, you might as well use libsoup. Number 4 on the list of popular modules was Commander. This is a library for parsing command line options. This one, it needs the same trick with Browserify that we did with number 2, Chalk, but I didn't even have to edit anything. In this case, the generated bundle just worked. Number 5 on the list was React. So this is a browser-specific thing. It doesn't really apply to writing desktop apps, because it's a library for making user interfaces, specifically in the HTML DOM. Although there is a library, React Native, which abstracts over different mobile platforms, and it allows you to write React apps for iOS and Android. And it would be really cool if this worked for the Linux desktop as well, but I think that would be a lot of work. Anyway, I'm going to skip the part of writing the actual code of Bloatpad. And I've linked to the code in my slides here, so you can click on it later if you're interested to see how I did it. But I'm going to go and share the actual app running. So I really hope that I can share a different window without breaking my screen share for the rest of the presentation. Let's see if that works. Can everybody see the app?
Yes, it looks like we can see it.
Cool. Okay, so I'm going to create a note. Let's see, what's my to-do list for May 13th. I'm a really bad typist under pressure while I'm giving a talk at the same time, so excuse my typos. Let's see, present talk, yes, and then other talks, and then after that, relax. You go back. The note is now in a list of notes. You can add another note. Other ideas for my app. Bloatpad for cats. You can go back and edit the notes, and there's a couple of other features that you get for free or almost for free here. You can really easily make an about dialog using platform APIs. You get keyboard shortcuts help, and that's it for the app. See if I can go back to sharing the talk. Okay, it looks like it's sharing on my end. So hope these are showing. Anyway, so now the app is done, you have to actually get users. So this is also like the way that we do this with desktop apps is quite different from the way you do it with a web app. This is actually one place where the desktop platform really has the potential to outshine the web, because it can actually be a lot easier with desktop apps. When you have a desktop app, once your user downloads it, they don't need to keep using your bandwidth and using your computing resources when they run it. So you don't need to run a server that has to scale really, really hard with the number of users. And what most people do is pay somebody else to do that. Your user downloads the app and they run it on their computer, and you can concentrate on answering bug reports like this cat is doing. So I'll be talking about building the app as a Flatpak and distributing it on Flathub. There are certain requirements that you have to meet in order to distribute your app on Flathub, but luckily the project skeleton that we generated early in the talk, it meets these requirements. There are only a few things that we need to fill in. One thing that will be kind of unfamiliar to people coming from the web platform is the AppStream meta info file. This is a kind of manifest that It provides the description that users see when they go to Flathub, like I've taken a screenshot of that here on the right. And users also see this information in their updater application. So Flathub requires you to have one of these because it ensures a good experience for users installing and updating the software. I've linked to a description of the file format here in the slides. But you don't have to write it from scratch. There's a generator. There's another link here to get you started. You go to this, click on this link, you fill out the answers to a few questions about your app, and the result of that process can actually just replace the file that was generated along with the project skeleton. You can just copy and paste it in. You will need screenshots for Flathub. These screenshots are linked in this manifest. So you have to host those somewhere, usually in your app's Git repository. And then for Flathub, you also have to have a content rating in this manifest. And so they use the scale given by the Open Age Rating Service. And that also has a handy generator. It's also linked in this slide. You can answer questions about your app, and it spits out a rating that you can download and just paste into your file. Another file where we have to fill in some blanks is the desktop file. And so this one is used not at the point of distribution, but this is used by the user's desktop environment to determine how to display your app, like where to put it in the applications menu, if there is such a thing in that user's desktop. And for the things, the one that was already generated in our project skeleton, we really only have to fill in the comment and categories fields. But I've included a link to the description of this file format in case you want to know what all the fields are. And then there's a list of categories that you can pick from. But the field is freeform, so you can pick any that apply or add new ones. You'll need an icon. The icon that I've shown here is the placeholder icon that you get from the app skeleton that's generated. I'm not going to go into the whole process of designing an icon, but one of the GNOME designers, who I believe gave a talk this morning, unfortunately didn't see it because it was at like 2:30 in the morning my time, but there's a very nice blog post on how to do this. And that's all for submitting your app to Flathub. There's instructions for actually doing the submission. The submission works as a GitHub pull request. And once the pull request is accepted, you've pretty much taken care of your distribution channel. And all you have to do now is fix bugs and push updates whenever you do. Hopefully, once your app is released and you get users, something that you might want to do is translate your UI into the languages that your users speak. So what you need to do this is a translation framework. And the platform heavily prefers one. It comes built in, and it's called gettext. It's been around a really long time, and it's quite well supported in all kinds of tools. The file format used in gettext is understood by a lot of existing tools, including translation websites such as Transifex, or you can get a program such as gtranslator or POEdit and kick off the process by translating the UI yourself into a language that you speak. So my experience having written an app, not talking about Bloatpad here, but once your app gets some users, translators are some of the easiest volunteers to find if you make it easy for them. It's a really low threshold way for people to contribute. They don't have to know how to program. It's really nice for them if they can just go to a website or download some program and translate the UI messages into their own language. It's quite low threshold, low friction. You've just got to make it possible for them. So we've gotten to the end. I think the conclusion is that it's quite possible, if you know JavaScript from some other context, to use that knowledge to develop apps for the Linux desktop. Some things might be really familiar to JS developers. Some things about the desktop platform might be even better, like being able to target one environment instead of a million different browsers. Other things might be worse or more confusing, like the situation with XML UI files. So what I'm advocating for us as desktop developers is to learn more about web and node development and try to reduce friction for this really large group of developers. But not everything should be copied, or not everything is even going to be applicable to desktop development. And that was my experiment. I hope it was useful to someone, because that means that it was successful. I'd like to take questions. I may have wasted the question time with the showing the slides in the beginning, but yeah, I wonder if there's a bit of
Philip, if you go ahead and
bit of
stop your
time.
screen share, there are questions in the shared notes that you can answer. Because this is the last session of the day, it's okay if we run a couple minutes longer, but essentially you have 3 minutes left of your formal time slot.
Okay. The first question is, isn't Glade UI deprecated for creating UIs? I don't think it is. It's still actively maintained for GTK3 UIs, and the maintainer of Glade is working on a version for GTK4. Hope that answers the question. Second question is for maintenance, which is better, XML, UI files, or code? It really depends on your preference. I think, personally, I prefer using XML files and making changes when I need to make changes in Glade. I know lots of other people who would really prefer code, so it's up to you. Which language is GJS built upon? GJS is embedded in it is a copy of the SpiderMonkey JavaScript engine, which is the same engine that's used in the Firefox browser. And so it's it's JavaScript plus the layer that that dynamically generates the bindings between these platform libraries and what the code that people write in JavaScript. Is there an easy way to add a WebView browser widget? It's not a stupid question at all. The person who asked this said sorry for the stupid question, but it's not a stupid question. Yes, there is. There's a platform library called WebKit GTK, and that that library provides a browser widget, and I believe it is part of the Flatpak runtime. So you already get that library for free. You don't even need an extra dependency. There's actually an example in the examples directory in the GJS repository. I can link to it after the talk in the chat, maybe. Question 5, can GJS be used cross-platform, Linux, Windows, Mac, Android, and iOS? The answer is sort of. It works on Linux and Mac. I have understood that it works on Windows, although I don't know how easy the developer story is for writing an app in it and packaging it on Windows. I would sincerely doubt that you could write an Android or iOS app with it. But who knows? That might be possible one day. How does GJS compare to Electron performance and memory-wise? I think that I don't have numbers at my fingertips right now, but Electron is basically an embedded WebView widget. So anytime you embed a WebView widget, your performance is going to go down a bit and your memory is going to go up a bit, because the web is web is a huge platform. Embedding a WebView widget is sort of necessarily going to increase the resources that you use. So the anecdotal evidence is that Electron apps, they, depending on what dependencies you use, they can use like easily 350 megabytes of memory or something. Still the answer depends on what dependencies you're using, but generally native desktop apps are going to be much more lightweight than that. And if you wrote it in a compiled language, it would be even more lightweight. But the interpreted languages that you can use for writing desktop apps, like GJS, Python, and stuff like that, they are generally going to be lighter than using an embedded browser. 6.1. Is it native code or is it JS runtime, GJS? Native code for GUI elements and JS for my logic written in JS. So the setup that we have here in GJS, like you're running a JavaScript interpreter, and that is calling into native code. So yes, I don't know if that answers the question. So yeah, like all of the code that you don't write is native code. Let me put it that way. Can this GJS be easily packed for Windows and Mac? I guess the the answer depends on what you call easily. For Mac, it's not too hard. For Windows, I don't have experience doing it, so somebody else might have to answer that. Question 8, is there HTTP2 support in GJS, and is it transparent? So GJS itself doesn't have any HTTP support because that's provided by the GNOME platform. So libsoup has that. I believe that HTTP2 support appeared in libsoup 3, which was released very recently. I don't know if it's in the current version of the Flatpak runtime or it's going to be in the next version. I'd have to look that up. Question 9, is WebKit GTK cross-platform as well, like available in Windows and Mac as well? I believe it is available in Mac. Windows, I am not sure. Question 10, will it have good compatibility with Qt? I'm not sure if, does it mean GJS in this case? But if it means GJS, okay, yes. The questioner is writing as we speak. So does GJS have good compatibility with respect to UI with Qt? It doesn't, because Qt has other other ways to write other language bindings. GJS is for implementing language bindings that are based on G-object. So yeah, you can use C libraries, but they have to be written in the form of G objects, and that's what GJS can sort of dynamically generate bindings for. There's a question 11 appearing. Let's make that the last one. The Rust story. I guess if you want to write part of, if you want to write native code in your app with Rust, you can, you can write it in the form of G-object introspection library, and then you can import that library in GJS. That's not something that I've done myself in any of my code, but I know that it's possible. Yeah. So let's call that the last question, because otherwise I'm going over time here. And before I go, I'd like to thank Andy Holmes and Evan Welsh and Sri Krishna for the discussions that led to this talk, and also their work on improving the GJS developer experience. And the presentation is licensed under a Creative Commons license. The details are in the slides. And you can find the code for the fake app that I wrote on GNOME's GitLab, and it has a permissive MIT license. So thanks very much, everybody, for listening.